Hello guys, so let's discuss the lead code weekly contest, that is 475. So I have done three problems in this contest, and the first one was easy and the second and third one was on medium level. So let's discuss the first problem, that is 3740, minimum distance between three equal elements, part 1. You are given an integer array nums. A tuple ijk of three distinct indices is good if nums of I is equal to nums of j is equal to nums of k. Means the both the three elements should be equal and should be distinct. The set. So the distance of a good tuple is absolute value of index I minus j plus absolute value of j minus k and plus k minus 1, where absolute x denotes the absolute value of x. Return an integer denoting the minimum possible distance of a good tuple. If no good tuple exists, return minus 1. So the problem is saying that we have to find three distinct indices such that the value in all three indices is equal, and we have to find the minimum distance, and the distance is defined as like this: the absolute value, the sum of the absolute value of the differences between indexes. So the example test cases are given and the time constraints are very less. So the brute force solution will work. Obviously, the first solution that came in my mind after seeing this constraint was the brute force one. So what I'm doing, I'm just using three for loops to check every element. If all the three elements are equal, then I'm calculating the distance and I'm putting that distance in my answer. The answer will hold the minimum distance. Till now we got. So first I've initialized my answer with int max. Then I'm starting my loop from 0 and jth from I plus 1 and kth from j plus 1. Means I'm taking three indexes. First one here, second, third. Then I'm moving my third index to check all the elements, and if my all three elements are equal, then I'm calculating the distance and updating my answer if it is minimum. At last I'm checking if my answer is int max, means there is no such indices that in which all the values are equal, so I'm returning -1, otherwise I'm returning answer. So this is the brute force solution for this. We can optimize it like we can check here itself if the I and j are not equal, then we can avoid this kth loop. Means if the elements in nums of I is not equal to nums of j, we can avoid the iteration for this for loop. So this is the small optimization we can add here, but yeah, this is the solution, and the time complexity for this will be O of n cube, because we are using three for loops, and in worst case all three can go till O of n. So O of n cube will be the time complexity for this, and the space complexity will be O of 1. So this is the solution for the first question. Let's move to the second question, that is minimum distance between three equal elements, part 2. So it is as same as the first question, but the time constraints are the constraints are high here, like n can go till 1e5. So yeah, so the only difference is in the constraints, and the problem is same. So now I think there's no need to explain the problem again. So let's move to the directly to the solution. So what I'm doing is I'm calculating the indexes. I'm calculating I'm updating my map. I've taken a map to store the indices of equal elements. Like if I'm getting, suppose let's take this test case. So yeah, so the for one I am putting indexes in my map, like 0th index, 1 second index and third index. For 2 I am putting the indexes wherever my 2 is present, so it is present on index 1. For 3 I am putting the indexes 0, 1, 2, 3, 4 at 4. So now what I am doing is I am putting all the indexes of the elements in my map, and then I'm iterating in the map to calculate the minimum distance. So here I am iterating in my map, and the I dot second mean this part will hold my vector. This is a vector, and if the vector size is less than 3, then I will simply continue, because no need to check for the elements. Otherwise I am iterating in this in this vector, and I'm calculating for all this uh, all the three continuous elements the minimum distance, because these are the indexes. So I'm calculating for this. Suppose here is 3 more indexes where it is present, let's say 1 1 1. So what I am doing is I'm calculating for these 3. Here I am calculating the distance. If it is a minimum, then it will update my answer. Then I am calculating for these 3. Similarly for these 3, and then for these 3. Means I am taking the 3 elements from my vector and calculating the distance through these 3 indexes and updating my answer. So yeah, this is what I'm doing in this, and at last I'm checking if my answer still contains the inmax. That means there's no such indices where all 3 elements are equal, so I'm returning -1. Otherwise I'm returning this answer. So the space complexity for this solution will be O of n, because I'm creating a map here. It will be approximately O of n, the space complexity, and the time complexity will be O of n here, because we are putting the elements in our map. Then this will be O of n log n. Why n log n? The overall time complexity will be O of n log n. Why? Because we are using an map. So the entries that I am pushing in my map will contain the log n operation, and for n elements it will contain O of n log n. Why this will not be O of n square? Because if suppose there are 3 elements, there are only 3 elements, and all 3 elements are distinct in my array, so it will take in the worst case it will take O of n. So this will not affect my time complexity. Yeah, this will not affect my time complexity. So the overall time complexity will be O of n log n, and the overall space complexity will be approximately O of n. So this is the solution for the second problem. Let's move to the third problem. So it is a standard grid problem, a DP on grids problem. So let's read the problem first. Maximum path score in a grid. You are given an m cross n grid where each cell contains one of the values 0, 1 or 2. You are also given an integer k. You start from the top left corner, that is 0, 0, and want to reach the bottom right corner m-1 n-1 by moving only right and down. So you can move only to the right or to the down. Each cell contributes a specific score and incurs an associated cost according to their cell values. So if there's 0 present in the cell, it will add 0 to our score, and the cost will be 0. If there is 1, it will add 1 in our score and cost will be 1. And if it is 2, means the cell contains value 2, it will add 2 our score and the cost will be 1. For 0, the cost will be 0, and for both the 1 and 2, the cost will be 1. Return the maximum score achievable without exceeding a total cost of k, or minus 1 if no valid path exists. So we have to find the maximum score that we can achieve within the given cost. Means the total cost should not be more than the k. If you reach the last cell but the total cost exceeds k, the path is invalid. It is obvious. So let's see the example test cases. So 0, 1, 2, 0, k is equal to 1. So this is the optimal path given here. And the constraints are also not high. Means it, from reading the problem, we can understand that it is a standard DP on grids problem with some tweaks and with some modifications. So yeah, so I tried to write this recursion solution, but then I directly moved to the tabulation solution for this. So let's see the solution, what I'm doing here. I will give a brief overview type because it is not possible to explain the whole solution without pen and paper. So I will give the brief explanation of this solution. So this MNN is the grid size, and I've created a DP vector. It will the DP vector will be 3D DP. 3D DP vector. Why? Because the ij, it will obviously change, and we have one more parameter, that is k, which will change. Why? Because suppose we reached to our end with suppose the k is 3 and we reached to the end with k is equal to 2. So we need to find the maximum score. So we can find that score for k is equal to 3, k is equal to 1, and k is equal to 2 also. That's why there's a 3D vector here. Now what I'm doing is the zeroth DP0, the zeroth cell of 3D DP will contain the 0, and not 0, that the value that is present in this, because what this is, let me show you like this. What this DP I, J and K, what this will contain? It will contain the maximum score we can achieve till ith row and jth column with k cost remaining, with k cost, because we are moving from the 0th to the kth cost. So this dpijk will give us this maximum score we can achieve till ith row and jth column with k cost. So this is the main logical part here. So what I am doing is I am just iterating in the rows and columns, and if my score is I can move to the right and or down. Okay, so down. So what I am doing is I am calculating dp of I, j and k. It will be the maximum of dp of I, means I can move to the right. So if I am at the ith cell, this means I can come here from the left column. So it will be I, j minus 1 and k. Maximum of this comma dp of I, and the up from the up. I can also come to the current cell from the uh, up of the current call cell. So this dp of ij will contain the maximum of this. So this will be our transition, and obviously we will add the values that is present in the current cell also. Let me do this current cell value. It will also contain the current cell value. Also we have to check whether this k didn't exceed. uh, why? Because we are updating our k with the current cell, means our k is dependent on the current cell. If the current cell value is 1 or 2, then we have to increase our k from 1, and if the current cell value is 0, then we can uh, use the current value of k. So this will be the logic for this problem. And then I'm just doing the standard checks and the as in the problem statement, as given in the problem statement. So this part is covered in the explanation. Now at last what I am doing, I am initializing a variable with -1, and I am iterating for all, checking for all the k's uh, to find my answer. Why I'm checking for all the case? Because this 1 2 3 4 5 6 7, suppose my k is given 7, for all the I'm checking for all the k, for all the case, because we can move to our bottom cell with any value less than equal to k. Suppose I hope you understand this. Suppose I can, there's no example given. I can reach to the bottom cell with 0, with all the cells having 0 values. Suppose the grid is given such that all the cells have 0 values, so I can reach to the bottom having cost 0, at cost 0. So that's why I am checking for all the values of k and taking the minimum from it. So this is the solution for this. The time complexity will be O of n square, O of n cube. Yeah, because the k also can go 10 raised to power 3, and this can m and n can go 10 raised to the power 2, means 1e2 1e3. So the overall time complexity will be O of m into n into k, and the space complexity will be O of m into n into k, because we are using this dp vector here. So this will be the time complexity, and this will be the space complexity for this solution, and this is the solution for this third problem. Yeah, so these are the solutions for the weekly contest 475. Yeah, thank you.